Okay, in the back. You guys, we're going to work on the first problem, 2011. It's last year's exam. You know, all the old ones I worked through many times. This one I worked through once. No, now it's twice because of last hour. Okay, so, and they like to throw a few little things in just to confuse us, or maybe make us feel less secure. And I'll share with you where I felt less secure. If you look through this whole packet, you should notice something about all the pictures. You could find areas under those, right? So that is a clue that you probably have to find some areas. So it's not bad. And they all look alike. If you read through this, I want you to do 2004, number 5 for sure for Monday. But the more you do, the better off you're going to be. All the grading rubrics are online. They're in the AB Solutions folder in Schoology. Yes, that's what we're going to do. We're going to do the first one together. If you've started, that's great. On the exam, you get 15 minutes of problem. So last year, questions 3 through 6, that's 4 problems. You were given an hour to work on all 4 problems. So think of doing 4 of these problems. But they're all different kinds. So it makes it a little trickier. And the reason the exam takes so long is because you have to stop during the exam to get your calculator out, put your calculator away. So it's probably one of the longest exams you take. Bring food for when you have a break. Pardon? You won't be done until at least 12:30, and you'll be gathering by 7:30. Yeah, it's a long time. But you have some breaks in between there. Okay, we'll do this problem. We will come back and hit on this topic again one more time before the exam, because this is such a big topic. As you can see, all the years, it's always there, this topic. And they put some other things in there too, so I can't say, like, this question's always this kind of problem. But you can see the theme. Okay, I have a continuous function on a closed interval, and the graph of f consists of 2 quarter circles and 1 line segment as shown in the figure above. My experience in the past with these kind of pictures is you should be able to read any point off this graph easily without writing the equation and without having a ruler. But in this particular problem, no, you're going to have to make your best estimate as to where that point is. To me, it should have been labeled. So that threw me a little bit for a loop. Okay, so there's g of x. It's 2x plus the integral from 0 to x of f of t dt. So the first thing I want to do is find g of negative 3. So I'm just going to do what it says. It tells me what to do, doesn't it? What's g of negative 3? Where you see this negative 3, you're going to put in for x. So g of negative 3 is 2 times negative 3. And please stop me if you have questions, by the way. Plus the integral from 0 to negative 3. Okay, so I don't know what to do. And actually, if you've practiced these problems, you're going to see something just like it, and you're going to do it. You're going to say, oh yeah, I know what to do. So g of negative 3 is equal to negative 6. Now be careful, that integral goes from 0 to negative 3. I don't like that. It's going backwards. It's going this way. And then I get all confused with negative signs. So why don't we fix that and make it go from negative 3 to 0, left to right, of f of t dt. And if I fix that, what happens to the sign out in front? It becomes negative. So that's an easy place to make a mistake. Everybody clear on that? And then all I have to do is find the area using geometry. So it's negative 6 minus, and I need the area of this quarter circle. Well, that's not bad, is it? Because it's backwards, and it's a quarter of a circle. So what is this area? Pi. And what's the radius? 3. And you could just write that down. You do not need to simplify that. because the radius is 3, right? So it's going to be pi, and it's 9/4. No need to simplify if you didn't want to, though. So if you left it pi 3 squared over 4, you got the points for that. Okay, and then it says find g prime of x. Now in the past, they usually say evaluate g prime of -3. Well, you have to find g prime of x first. And you get points for that, but they're being really clear on this problem. Not always. As we go through the problem, I'll show you some places that can get not very nice. So I want to find g prime of x. Well, g of x is equal to 2x. I'm just going to recopy it. Plus the integral from 0 to x of f of t dt. And I want to find g prime. So I'm going to take the derivative. d dx. Yes, ask. I went back to the original function as written. And if I remember this theorem, it has to be from 0 to x. Remember that second fundamental theorem? Which is why they gave it to you 0 to x instead of x to 0. Either you're going to get messed up with the sign one place or the other. So this is g prime of x. What's the derivative of 2x? 2. And what's the derivative of the antiderivative? That's the second fundamental theorem. It's just g of x. Remember, that's all you have to do is put this in there. Don't get too... When you look at the symbols and they can be scary, but if you realize it's just this derivative will undo that antiderivative, so it's f of t but evaluated at x. So it's 2 plus f of x. So I want g prime of -3, which is 2 plus f of -3. It's clear what my intention is. The symbol with the S symbol with the dt means find the antiderivative of whatever function's in there. So it's a symbol. It's like adding 2 and 3, 2 plus 3, and you get 5, right? The plus symbol went away. Okay, what's f of -3? It's right there. Everybody see that? It's 0. So this is equal to 2 plus 0. I'm going to show my steps so it's clear, which is 2. Okay, so how about our points? Some of you worked ahead, which is good. Did you get your 3 points? That wasn't that bad, was it? And sometimes you might get stuck on part B, but be able to do C. I'll tell you what I did with B, which I thought wasn't very nice on their part, actually. It says determine the x-coordinate of the point at which G has an absolute maximum on a closed interval. So I did the problem, and you can do the problem. Wouldn't hurt us to do that way. I just want to evaluate G at the endpoints and at the critical point where the derivative is 0. That's the max-min existence theorem. That's not how the graders did it. It shocked me when I looked at that because this is begging me to use the max-min existence theorem. Instead, they actually just do a first derivative test. So where would our candidate be? I certainly would look at -4 and 3, but finding those areas, well, it's not that bad. I can still find those. Well, I got to figure out where what? Where am I looking for where the derivative is what? Changes from positive to negative. Be careful. And I know I would have to bet that most people did choose 1.5, but that's not correct. Now, if you chose 1.5 and you said that the derivative goes from positive to negative, I think you would get that point for the justification because your thinking is correct. I didn't grade this one, so I don't really know. But we have to go back and look at our derivative. Our derivative is not f. What is our derivative? Yes. I thought that was really tricky. And then I'm looking at it and saying, well, I must be doing that wrong because I can't read that point off the graph very well. No, I wasn't wrong. So I want to know where the derivative is 0. Now, if you make that statement, if you're really clear on your intent, I want to know where the derivative is 0, but I misread it, and I forget about the 2, and I say it's 1.5. But the fact that I said this gives me the first point. And then if I have my justification that G prime goes from positive to negative, that gives me my second point out of 3. I won't get the answer point because the answer point's not right. It isn't 1.5. So where is this 0? 0 is equal to 2 plus f of x. So f of x, my y value, is equal to what? -2. And to me, this was just fuzzy because I know it's a line, and I suppose you could write the equation of the line. Sometimes they do expect you to do that because you can get the exact answer if you do that. So here's -2. And where is this on the x's? About. Be safe, assume it's not going to be thirds. So it's 2.5. So you get a point for that. So x equals 2.5. And G prime goes from plus to minus. So there's my 3 points. Joe?
If it's not labeled, we can put it.
You have to. I mean, well, actually, no, you don't have to. And we'll look at some of those problems before we take the exam one year where you actually had to write the equation of a circle. You had to do it. I didn't like that one either. They don't do it very often, but they do often do it, so you got to be careful. The other way would be to, this is the way I approached it, was to find G of, what was my left endpoint? -4, G of +3, and G of 5/2. And find out which is the biggest. That's the most direct way. But I would say max-min existence theorem. Yes. Yeah, this is not the graph of the derivative. This is the graph of f. G is 2 plus that integral. It's a shift. G prime is equal to 2 plus f of x. So it's this graph shifted. So this is where my derivative goes from positive to negative. Okay? Okay. If you want me to find those areas, I will, or we can come back and do it at the very end. Because you got to find some areas anyway. By the way, if you read your graph correctly, why I messed up is because I'm looking at the smartboard from the side. I didn't realize this was at 1.5. I thought that was at 1. You guys tell me what's true here about this area and this area. They cancel each other out. So that's kind of nice. Yes. We're going to go to C next, yes. I just was talking about B. I think it was B. So that was 3 points. But you get your point for stating it's 0 and giving a valid reason as to why you chose that point. I would have to bet that probably 80% of the students on the exam probably selected 1.5. I almost did that. I go, wait a minute, my derivative is not a function. So I have to be careful with that. You can read the commentary if you go to AP Central. I don't have that up on Schoology, but if you want to go read the commentary, and you'll see where the students made the mistakes. And they'll tell you what the average score is. So I'm going to say this was probably in the 4 range, and I have that written down someplace. I just don't know where. Okay. C, find all values of x on the interval for which the graph G has a point of inflection. This is only 1 point. So I like to justify my answer first. So where are my inflection points? When what? Better than? Where do I get inflection points?
I really don't know.
Where the second derivative changes sign. Change it. All it has to do is change sign. There's my reason. I'm going to look at my graph, and I'm going to look to see where the second derivative, what is the second derivative? If G prime is equal to 2x plus f of x, what's G double prime? F prime of x. So I'm safe. They made it x squared. Well, that would have been trickier. Okay, so I'm going to look at where the f prime of x is going to be changing sign. So I'm looking at the slope of my tangent line. So that's positive. That's positive. It's undefined here, it looks like. I know it is. It's positive, positive, positive. It hasn't changed sign yet. Positive, and now what? Negative. So where is that? At x equals 0. Does it change sign again? Nope.
But you technically use 0 because it's
You use it because it changes sign. The second derivative is undefined. That's okay. Inflection points occur with the second derivative. Candidates are when the second derivative is 0 or undefined. If the second derivative is 0, well, I'm thinking second derivative test. You just have to check to see if the signs change. So there are two places where it was undefined. It was also up here at x equal to -3. Because if you were to draw your tangent lines on your circle, on a circle at that endpoint of that radius, it is undefined. It's a vertical tangent. Okay, so that was one point. You got the point for writing what I wrote. So we got this, and plus the point for the reason. Now you got to make it clear to the reader. If we are not clear about what you're trying to say here, then you're not going to get the point. Let's look at that. Did they say anything about that? Let's see. That's the one we just did. I would have to think that you would have to make this statement and then say it changes sign. I can't really move it up. G double prime of x equals f prime of x. Okay, I'm not going to swear to it, but why not be safe? Okay, and the last part. And then don't do what I did. Don't misread it. Read the problem. It says find the average rate of change. Now, okay, you guys? Average rate of change. Is it asking for the average value of a function or the average rate of change? Yeah. So what I did in the class, I read it as average value. So it's very easy to do. So when you see average, read it twice. Make sure you're clear in your head if it's a slope or if it's an antiderivative. Okay, so this is D. What's the average rate of change? How do you find it? That's right. It's just the slope of the secant line. And we are doing this between the endpoints. Is that right? Oh, I hate this. So I'm going to do f of negative, and I want a f, not h. So it's f of -4 minus f of +3, is it? Yeah, it must be. Over -4 minus 3. What's f of -4? It's -1, and that's why they gave me this. See what I'm saying? They were very clear about these points, but they aren't really clear on those other ones. And you could write the equation line and actually prove they are what they are. And then it's going to be -3, right? So this is -1 minus a -3 over -7, which ends up getting me -2/7. I'm looking at my picture. Is that right? Looks pretty good, right? And then it says, there's a statement here, and you might have to read this a couple times. Because first off, this is run into that. That's part of my problem. It says, there is no point, C is between -4 and 3, where the derivative, the instantaneous rate of change, is equal to the average rate of change. Do you remember that's the mean value theorem for derivatives? Explain why this statement does not contradict the mean value theorem. Because remember what the mean value theorem says. Do you remember? Okay, mean value theorem states we have f is continuous. What else? And differentiable on a closed interval. It has to be on the interior. And this is AB. It's got to be continuous on a closed interval and differentiable on the interior. And then, remember what the picture looked like? I'll just draw any old function here. And I'm going to draw a secant line here. Here's A. That wasn't a very good picture. Sorry. Here's B. And that this is saying that the slope between A and B on my curve, that someplace that there will be a tangent line so that these are parallel. So the slope of the tangent line is f prime of C. So the mean value theorem states that I should be able to find a slope equal to negative 2/7 on my graph. And it says explain why. They tell you it's not. It says there isn't any place where my instantaneous rate of change is equal to negative 2/7. I'm just going to have to believe them. But, you know, if you look at the picture, can you find a negative? These are all positive slopes on the left side here. On the right side, this is a constant negative slope. It's not equal to negative 2/7. Matt? Oh, I'm sorry. I goofed. Okay, so I was just thinking, kind of thinking out loud there. So it isn't. Well, why does that not contradict the mean value theorem? Right. For the mean value theorem to apply, mean value theorem, and I would write does not apply. I wouldn't assume that all the readers know that that means does not apply. Okay, just to be on the safe side, because f is not differentiable on the interior.
Can you just say that you have to explain how there's no other line to do?
They tell you that it doesn't exist, so you're okay. You don't have to explain it. You just have to say it does not apply. Here's the key thing. It's not differentiable. Let's look and see what the scoring rubric says. Now, when we get these scoring rubrics, we get this, and then we spend an hour taking notes and writing, and my scoring rubric is full. Or else I have another piece of paper where I write all my notes. Because this, I thought this was a pretty good way to decide if you're going to get points or not. It is not a good way to do it. There's a lot of more things because they take about, I think they take about 100 of the exams, and they grade them before they give them to us. And they find all the mistakes that students make. And then they brief us on all these things. Here's what the students did wrong, like the 1.5. I'm sure that's going to be something that they would have probably talked about with this group. And how they were going to treat that. Are they going to give them that last point, or are they not going to give them the last point? So that everybody does the same thing. And then we have our table leaders, and they reread, they rescore your exam to make sure that we're doing it right. And I think I was only called on it a couple times where I didn't do it right. And then once that I've established that I'm doing this correctly, then they leave us alone and we just grade, and they grade too. But there's a lot of checks in there to keep you guys safe. No. Average rate of change, negative 2/7. We did that because you want to do well on the exam. That's why. No, you're not. You're going to do these problems. You're going to define. If you do this, it's still not too late. It's still not too late to be ready for the exam. Okay? You guys, the question was, it says, well, how to explain? I said F's not differentiable. There it is. Make it clear that you know what the mean value theorem says. Because they gave you this, I would have listed the conditions and said the function has to be differentiable, and it's clearly not differentiable at x equals 0. That last answer point, but like I said, I didn't get briefed on this, so I don't know how picky they were about that. I've only done this 2 years, but wealth of knowledge in 2 years. Wow. Do you have questions for me on registration even?